Today we will study glycolysis in detail. Glycolysis, as the name indicates, it is the lysis, that is breakdown of glycogen. One molecule of glycogen breaks into two molecules of pyruvic acid. It was discovered by Amden, Meyerhof and Parenes. Firstly, there we can see it is 6C sugar glucose. In the presence of hexokinase enzyme, this reaction will take place. ATP, that is adenosine triphosphate, will donate its 1-phosphate to glucose, and the glucose will become glucose 6-phosphate, that is 6C sugar, and 1 ATP will be reduced. Here there will be loss of 1 ATP. This step is called phosphorylation. And this next step, called isomerization, the glucose 6-phosphate 6C sugar in the presence of phosphoglucoisomerase will convert it into fructose 6-phosphate, which is also a 6C sugar. Then in the next step of phosphorylation, again there will be the addition of phosphate. In fructose 6-phosphate, the ATP donates is 1-phosphate in the presence of phosphofructokinase and Mg2+. There will be formation of fructose 1,6-diphosphate, which is also a 6C sugar. Also, there will be a loss of 1 ATP. In the both steps of phosphorylation, we see 1 ATP is lost. That is, there is loss of 2 ATPs in these two steps. The next step is cleavage. Cleavage means this breakdown of this molecule fructose 1,6-diphosphate 6C sugar. In the presence of fructose diphosphate aldolase, it will be breaking down into dihydroxyacetone phosphate and glycerol aldehyde 3-phosphate. These both of molecules are interconvertible. So we will consider that there are two molecules of glycerol aldehyde 3-phosphate, which is also a 3-carbon sugar. So these all steps, phosphorylation, isomerization, phosphorylation, cleavage, were preparatory phase, that is phosphorylation of glucose and its conversion into glycerol aldehyde 3-phosphate is preparatory phase. Here there is only loss of ATPs. In next stage, the pay-on phase, we will gain the ATPs. Now after two molecules of glycerol aldehyde are there, glycerol aldehyde 3-phosphate are there, the next step is phosphorylation and dehydrogenation. In phosphorylation, here the phosphate donor will not be the ATP, but here the phosphate will be donated by H3PO4, which is phosphoric acid. It will donate its 2-phosphate into 2-glycerolaldehyde 3-phosphate. That is why it is known as phosphorylation. And in dehydrogenation, there will be loss of hydrogen atoms. So 2NAD, which is also known as the universal acceptor of hydrogen, will take hydrogen atoms from here, and there it will produce 2NADH plus 2H plus. In this reaction, 2-glycerolaldehyde 3-phosphate will be converted into 2,1,3-diphosphoglycerate in the presence of glycerol aldehyde phosphate dehydrogenase and the cofactor Mg2+. In the next step, there will be dephosphorylation, which is commonly known as the loss of phosphate. So ADP will become and take its 1-phosphate, its 2 phosphates, 2 ADPs will come and they will take their 2 ATP. This will happen in the presence of phosphoglycerate kinase, and 2,3-diphosphoglycerate will be converted into 2 into 3 phosphoglycerate. Now the next step is only a rearrangement of 2 into 3 phosphoglycerate. 2 into 3 phosphoglycerate, 3 carbon sugar will be converted into 2 into 2 phosphoglycerate in the presence of phosphoglycerate mutase. There is next step of dehydration, in which there will be loss of water, that is H2O. Phosphoglycerate in the presence of enolase enzyme will be converted into 2 into phosphoenol pyruvate. Then in the last step there will be recovery of the atoms. 2 atoms were wasted, 2 ATPs were wasted in the phosphorylation 1 step and 3 step, and 2 ATPs were recovered in dephosphorylation 6 step, but in 9th step we will gain the ATPs overall. So the phosphoenol pyruvate will be converted into 2 pyruvate in the presence of pyruvate kinase. 2 ATP will take their 2 ATP. Net gain will be 2 ATP. In this dephosphorylation process, the 2-phosphoenol pyruvate will be converted into 2-pyruvate, which is its main goal. So, this phase is known as payon phase, the conversion of glyceraldehyde 3-phosphate into pyruvate and couple formation of ATP. This was the description of the glycolysis. Thank you.